In question 4, we're going to build the federal funds market and then show how the Fed targets interest rates. The numbers for the demand curve and the numbers for the supply curve have all been copied and pasted into Excel. Just like in problem 2, the intercept of the demand curve is the sum of C7, which is the shock parameter, plus the product of the reserve requirement ratio, 0.1, and checkable deposits, 521.5. So the intercept is 6.12. The slope is the aversion to holding excess reserves, 0.05. The vertical section is the sum of barred reserves, $0 billion, and non-barred reserves, $78 billion. The horizontal section of the supply curve is the discount rate, 3.22%. So down here we have the supply curve, which is this part of the dashed cross, and the horizontal section here. It's the L shape right here. The demand curve, and then the equilibrium is right here. I've copied and pasted the diagram from Cengage Now here into Excel. The supply curve is the L-shaped part of the dashed cross that starts at $78 billion, goes up until the discount rate of 3.22, and then goes right. The equilibrium federal funds rate is the interest rate at the intersection of demand and supply. The equilibrium federal funds rate is roughly 2.2%. Next, we want to actually calculate the equilibrium quantity of reserves, equilibrium federal funds rate, and the Fed's target for the federal funds rate. The equilibrium quantity is just 78. The target is 1 percentage point less than the discount rate. So if the discount rate is 3.22, the target is 2.22. The federal funds rate is determined by plugging the quantity of reserves into the demand for reserves. And that equals 2.22. So it looks like the federal funds rate is equal to its target. Which of the following statements is correct? The equilibrium federal funds rate is equal to its target. That is true. The federal funds market is in normal mode. That is true. So C and D are not correct. So A and B are true. Strong economic growth causes demand deposits to surge by $15.9 billion. With demand deposits now at $537.4 billion, 7.71 minus 0.05 R. I'm going to copy the new intercept. The slope is still 0.05. Down here we have to compute the new equilibrium. Since the reserve demand curve is now on the horizontal section of the supply curve, quantity of reserves have increased. And the federal funds rate is now equal to the discount rate. So the equilibrium federal funds rate is 3.22. The target is still 2.22. To get the quantity of reserves in the banking system, we have to replace IFF with 3.22 and solve for R. Here I've set the new demand curve, 7.71 minus 0.05 R, equal to the new equilibrium federal funds rate. Then I subtract 3.22 from both sides and add 0.05 R to both sides. Then I divide both sides by 0.05 R. So when I do the calculation, I get, for the equilibrium quantity reserves, 89.8. Since the federal funds rate is greater than its target, to get the federal funds rate back down to its target, we have to do an open market purchase. The size of the open market purchase is the difference between this value at the new supply curve and this value at the old supply curve. To calculate this quantity of reserves, we have to substitute the equilibrium federal funds rate into the new demand curve. So we have to change 3.22 to 2.22 here, here, and here. So the new equilibrium quantity of reserves is 109.8. And the size of the open market purchase is the difference between the new level of reserves and the initial level of reserves. The new level of reserves is 109.8. The initial level of reserves is 78. So the open market purchase is 31.8. That open market purchase of $31.8 billion will lower the federal funds rate from 3.22 to 2.22. If the excess reserve ratio is 12% and currency ratio is 2%, with a reserve requirement ratio of 10%, the money multiplier is what? This is the equation from the PowerPoint for Chapter 6 of my textbook. The excess reserves ratio is 0.12, currency drain is 0.02, reserve requirement ratio, which can be denoted as rho or RRR, it's 10%. So the money multiplier is C, 0.02 plus 1, divided by the sum of these three, and you get 4.25. To get the increase in the money supply, you multiply the open market purchase by the money multiplier of 4.25, and you get an increase in money supply of $135.15 billion. Next, most checkable deposits are lower than normal because an abnormally harsh and long snowy winter has slowed commerce, and this has caused reserves demand in question B to shift from the red line back to black. When demand shifts from red back to black, the federal funds rate drops below 1% in my example. To get the federal funds rate back up to the target, we have to reverse the open market purchase. So we have to do an open market sale that was equal to the open market purchase. To undo the open market purchase is $31.8 billion. And that is needed to raise the federal funds rate from below 1% back up to the target of 2.2%. And that will reduce the money supply by a negative 135.15 because this is a sale. So this is a negative change in reserves. So suppose checkable deposits fluctuate in a way that causes reserves demand to continuously balance about the red and black lines in question B's graph. To keep the federal funds rate at its target, the Fed must continuously conduct open market purchases and sales. Doing this causes oscillations in the money supply, which cause the nominal rate of interest to fluctuate. Hence, the Fed can target the growth of money or interest rates, but not both. I'm going to check my work, and I should get everything but part E, which I leave to you, correct. And it looks like I get everything correct, but the numbers in part E.